In this lesson, we are going to learn how to calculate the R value, the correlation coefficient. So what we're going to do first is we are going to take a look at that table there. They're giving us the values for a femur and a humerus. They don't tell us what kind of fossil it is, and I believe this is in centimeters. So let's go ahead and say we're in centimeters here. Okay. The formula below is kind of complicated looking, so we're going to go through and do this by hand. And we're going to go ahead and take 1, so the formula here, R equals 1 divided by n minus 1. Remember, this is your term number. So in this case, we have 5 values. So our term number would be 5. And then it looks like here we have the data value minus the mean. Remember, x bar is the mean, and then divided by the standard deviation. That sounds like standard score, doesn't it? That's how we find the standard score. So we'll do that for the x's and the y's, and then we multiply them, add them up, and go from there. So we're going to do all of this by hand, just to make sure we understand where these numbers are coming from. The first thing we have to find is the mean and standard deviation for the femur and the humerus. So I'm going to go back to this screen actually, and I'm going to add up all of these numbers to find my mean. So when I take 38 plus 56 plus 59 plus 64 plus 74, I get 291 divided by 5 numbers, and it looks like my mean is 58.2. I'm going to go ahead and do my humerus, so I'd go 41 plus 63 plus 70 plus 72 plus 84. I get 330 divided by 5. So my y bar, because it's the mean of my y values, would be 66. So on this page, let's plug that in. My x bar, a mean of my sample, for x is 58.2, and we're in centimeters, right? And then my y bar would be 66 centimeters. So now we need to calculate the standard deviation. So in order to calculate the standard deviation, if you remember doing that, and this is from your test also, so hopefully this is a good memory for you from your Chapter 13 test, you're going to take your data value minus the mean, so 58.2, and then I'm going to square it. So I would like you guys to pause the video and plug in all of those values. So for this one, when I take 38 minus 58.2, I'm actually going to, let me rewrite this so it's over here a little bit so I have more room since mine's so thick. So I take that value minus 58.2, I got negative 20.2, and when I square that, I get 408.04. Remember, we round to hundredths. So take a couple minutes and do your x and y chart. And fill all those in, and then we'll see where we're at, okay? Alright, so that's filled in. So now remember to find your standard deviation. You add up all these numbers right here. So I'm going to find the total of all that. So we add those. And when I add those all up, I get a total of 696.8. And then I'm going to divide by n minus 1. So I'm really dividing by 4. And so when I take 696.8 divided by 4, I get 174.2. And then I take the square root of that for my standard deviation. So my standard deviation for x is 13.2 centimeters. Same thing for my y's. I add all of those up and I get 1010. I'm going to divide by 4 still. So I would get 252.5. When I take the square root of that, I get a standard deviation of 15.89. So now that's nothing new. We've done this before. This was just all by hand. As I move over here, I have to find the standard score for each one. So remember, that's where you take your data value minus the mean divided by the standard deviation. So for this first one, I take 38 minus 58.2, which is my x bar, divided by 13.2, equals negative 1.53. So if I would have calculated my mean or my standard deviation wrong, wouldn't all this work be wrong? Yes. So it's very careful to be very precise in your work and make sure that you're looking at those things and writing those down correctly. So keep going. So here I'll take 56 minus 58.2 divided by 13.2. I get negative 0.17. Move this down so I can keep going. So 59 minus 58.2 divided by 13.2 is 0.06. 64 minus 58.2 divided by 13.2 is 0.44. 74 minus 58.2 divided by 13.2 equals 1.20. I'd like you guys to do the y's, please. So now when you do the y's, I'll start you out. 41 minus 66 divided by 15.89, because that's what we found for those. So go ahead and do all that. Now, after you get that table filled in, this last column here is telling you to multiply those numbers. So I'm going to be taking and multiplying what I just found for my x and y here. So negative 1.53 times negative 1.57. And when I multiply those, I get 2 point, and I'm going to round 4 places here, 3 to 4 places depending on what I get, just so I have a little bit more. I'm already rounding so much, my answer is going to be off a little bit. So I sometimes write a few more decimal places here. Oops, I meant to say times there. So as I go through and I'm multiplying these numbers, remember, so I'm taking my answers and multiplying them. This times this would be, I'm just going to go ahead and put that here, 0.44 times 0.38, I got 0.1672. 1.2 times 1.13, I got 1.356. So now, this is what you do every time you're finding your correlation, your R value, your correlation coefficient. So now I total those. So I'm going to add up all these numbers together. And when I did that, I got 3.9726. So I have to divide that by 4, because it says divided by n minus 1. If you're wondering where all this is coming from, let's go back here and look. This is where we're at in our formula. We've just done this right here. That was our total we just found. The reason we added these all up is because of this summation symbol. And then it says times 1 over n minus 1. So really you're dividing by n minus 1. So that's why we're dividing by 4 right now. So we are almost at our answer. Oops. So now as I divide by 4, I get 0.99315. So if I was asked to describe this, because our number is so close to 1, we know we have a very strong positive correlation. Remember, that's what our number tells us. And what that means is, as the femur length increases, so as femur length increases, humerus length increases. That's what we just found. Now, hopefully you see that's kind of a lot of work, and I would expect you to be able to do that on a test. If you were given the formula and I give you these tables, I expect you to be able to fill all that out so you understand where it comes from. The nice thing about this is that your calculator also does this. So when I go to my calculator, I'm going to go into Stat, Edit, and I'm going to enter my data into List 1 and List 2. Then we hit Stat, Calculate, and we're going to choose the number 4, and then I hit Enter, and then I'm going to type L1, L2, so second L1, comma, second L2, and then I hit Enter, and I have a go to. Oh, it doesn't like that. Here, let me see if my diagnostics just need to be turned on, because I think that'll just show up right away. Let me go to second 0, see if your diagnostics are on. I don't know if this has diagnostics, so it might not work on here, but we'll try. You'll go down to the D's. Your diagnostics should be on. We turned them on last try, and they shouldn't, unless someone reset your calculator, they should still be on, but some of you have had to reset. So here, diagnostic on, see that? I'm going to hit Enter. Diagnostic on, I hit Enter one more time. Let me try this again. Stat, Calc. I'm going to go number 4, and right here I'm going to hit second L1, comma, second L2. I think that's where we want that. There we go. So ignore, after it says, I actually picked 4, that was my problem, instead of highlighting the 4 and hitting Enter. And then I type L1, L2, If those are the only two ones you have data in, it should still work. And now it'll give me my R value. So see that R value right here? 0.9941. And what was ours again? Ours was 0.9931. So the calculator gave us 0.9941. Now, which answer's better? The calculator's, because we rounded in our answer, right? And since we rounded, that's going to make us off a little bit. But we were still really close. It doesn't make us off too much. So we would be able to get a valuable answer by hand also. So if your calculator doesn't work, if you have any questions, make sure you let me know tomorrow.